Okay, in this video you are going to learn about acceleration and how to calculate it. Before you continue on this video, you are going to be taking notes and you're going to have to look at the video to take your notes. So right now you should have the title, What is Acceleration and How do we Calculate it? And titled Acceleration Cornell Notes. And our first topic is going to be acceleration. Acceleration is basically a measure of an object's changing velocity. So if we're changing our velocity, we have acceleration. Okay, so now what we're going to do is look at some examples of acceleration, some examples where we're changing that velocity. So the first one we're going to look at is anytime you have an object falling from the sky, you're going to have acceleration because as these objects fall, they're going to be going faster and faster and faster until they hit the ground. So this is an example of acceleration because as they're falling, they're getting faster and faster. Another example is when a car is slowing down for a stop sign or when a runner is speeding up. So again, anytime we're changing the velocity, we have acceleration, even if it's decreasing. So we have, in this example, if a car is slowing down, the velocity is, in this case, going to the right, but its acceleration is in the opposite direction, or what we would call negative acceleration. But we're still calling it acceleration. Okay? Or if a car is speeding up, we have positive velocity, or velocity going to the right, and the acceleration is going in the same direction, so we say the car is speeding up. Okay, and finally, our last example is where the object's speed is staying the same, but it's changing direction. And so because the direction's changing, we also have acceleration. In this case, we have a planet orbiting the sun. So in this example, we have a planet going around the sun, and this arrow is representing its velocity. So when it's at this point, the velocity is going, according to this picture, straight down. Over here, it's going to the right, and then it's going straight, and then it's going to the left. So as it's orbiting the sun, we have our velocity changing direction, and because of that, we have an acceleration. So make sure you have these points copied down. If you don't, you might want to pause the video, get it all copied down before moving on. Okay, so now for our next topic, we are going to need to learn how to calculate acceleration, which means we need a new equation. Okay, acceleration is just basically how fast or slow is that velocity changing. So we need to know how much the velocity is changing and how much time that took. So we're going to need to use this symbol delta. Delta means change. So this is the equation that you're going to get on the test, but you're going to need to know what that delta means. So delta V means that it's your final velocity minus your starting velocity. So how fast were you going in the end? How fast were you going before you started, and subtracting that and dividing that by how much time that took. Okay? Or your final time minus your starting time. Oftentimes this will just be given to you. You don't need to subtract it, but you do need to subtract your velocities. And we need to know that our units are meters per second squared. Okay? So go ahead and copy this down and then go to the back of your notebook. Okay, in the back of your notebook, you should already have this copied down. If you don't, go ahead and copy it now. But we're going to start making a running list of all of our different variables and our abbreviations and our units and our equations, because from here on out, we're going to keep getting more and more equations. So far we know that distance is a name of a variable, and its abbreviation is d. And a lot of us are getting confused between the variable and the unit. The variable is what letter is represented in our equations. The unit is generally what we measure it in. So in this case, a common unit, the units that we're going to use mainly, is going to be meters for distance. Okay, time is abbreviated as T, so that's going to be the variable that shows up on our equation. Okay, the letter that is in our equation, not the units. But oftentimes we find time in seconds. And then we've already learned about the speed or velocity equation, and that's going to be abbreviated either as an S or a V, and they're going to pretty much be the same thing. So when we say speed, or we can talk about velocity. When we say velocity, we could talk about speed. Only difference in velocity is that it also says what direction we're going. But for the most part, they're pretty much the same. So our units, since we're mainly going to be using meters for distance and time is mainly going to be seconds, we are going to be using meters per second as our unit for speed. And we also have this equation. So when I say equation, I'm talking about what are the letters that we're going to substitute in to find what we're looking for. Okay. Now we've added on a new equation. We've got acceleration. It's going to be abbreviated as a small a, and its units are going to be meters per second squared. And in the examples, I'll show you where this second squared is coming from. So our equation is going to be acceleration is equal to the change in velocity divided by the change in time. These are the two things that you will be given on the test. You do not have to memorize this. But you do need to know what all of this is. You need to know what the abbreviations are. You need to know what the units are going to be so you understand how to use these equations. All right, so let's go ahead and see how this is all going to work out. So in your notebook, you should already have this page glued down. So go ahead and find this in your notebook. The top of the page, we have acceleration is equal to change in velocity divided by the change in time. And to break that down, basically that means is what's your final velocity subtracted from your initial velocity. And we use these little subscripts, these little letters by our V to indicate what type of velocity is. So down here you'll notice that VF is equal to your final velocity, VI is equal to your initial or starting velocity. T is going to be equal to your time, both final and initial, and A is equal to your acceleration. One hint when you're doing these problems today is that a lot of times your initial velocity is going to be 0. Okay? So whenever you see these words like stopped, at rest, or still, that just means it's equal to that number. Okay, so let's do this first problem together. So we have this problem with a cyclist. So we have a cyclist accelerates from 0 meters per second to 8 meters per second in 3 seconds. What is his acceleration? So we're going to do our first step, which is to write our knowns and unknowns. So the question is, what is his acceleration? So A equals to, I don't know, question mark. And I know from my notes that my final unit is going to be meters per second squared. So I want to make sure I have that in mind as I work my problem. Okay? My final velocity, according to where I ended, was 8 meters per second. So I'm going to pull that down too. My other number I was given was this 0 meters per second, and that's going to be my initial velocity. And the time it's going to take is 3 seconds. So now what I'm going to do is I'm going to use my equation that acceleration is equal to my change in velocity, which is my final velocity minus my initial velocity, divided by my change in time. And I'm just going to actually say, you know what, I'm just going to make it a t. Now I'm going to do my substitution. Acceleration is equal to, well, VF is equal to 8. So I'm going to write 8, and I'm going to keep my units there, meters per second, minus 0 meters per second for my initial velocity. And then I'm going to divide that by my time, which is 3 seconds. All right. Now I have to use my order of operations. So I'm going to do my first step. 8 minus 0 is 8. So I'm going to have 8 meters per second. And I'm going to divide that by 3 seconds. So now all I have to do is my calculations. So I'm going to bring up my trusty calculator here. And I'm going to do 8 divided by 3. And I get this really funky number, so I'm going to round it to 2.7 because that 6 rounds up to a 7. So I'm going to do 2.7. Now comes my units. Notice I have a meter on the top and I have a second on the bottom. But then I have another bottom, which is another second. So I'm basically saying that I'm dividing by 2 seconds, which is another way of saying that is I've got a meter on the top and I've got 2 seconds on the bottom. Second times a second is equal to seconds squared. So my units are meters per second squared. And that's where that second squared comes from. I'm going to put a box around that to indicate that that's my final answer. And I'm done with that one. Okay, let's try our second problem. And what I suggest you do is pause the video, try it out, look at the example on number 1. It's going to be almost exactly the same thing. And then check your answer. So I'm going to go ahead and solve this out. Hopefully you've tried this, so now you can check your answer. So first step is we need to do our knowns and unknowns. So I've got some numbers here. I've got my 4 meters per second. I've got 22 meters per second. And I've got 3 seconds. I didn't even read the problem yet. All I did was go, oh, I got a number here with this unit. I've got 3 seconds, and I've got 22 meters per second. I just wrote them down. The question is asking what is its acceleration. So I now know what my unknown is. It's A equals my question mark. I'm going to go back to my cheat sheet here. I find out that A is equal to meters per second squared. So just so I remember at the end that I'm looking for meters per second squared, I'm going to go ahead and do meters per second squared. Okay, so now I have these 2 velocities. One's going to be my starting, one's going to be my ending. So here it says initial. So initial velocity means I'm going to put this little I there. And over here it says final velocity is 22. So I'm going to put a little F here to indicate that that's my final. And then that's 3 seconds. So that is my time. All right, so now I'm going to use my equation. Divided by t. I'm going to do my substitution. So my VF is 22 meters per second minus 4 meters per second, all divided by 3 seconds. Now I'm going to do my solving. Okay, bring up my trusty calculator. I've got 22 minus 4, which is going to give me 18, divided by 3 seconds. 18 divided by 3 equals 6. And my final units are going to be meters per second squared